All right, I wanted to jump on and go over one of each type of problem, and this is a review from all the factoring we did back in chapter 5. So 6.4 factoring practice by concept. In 6.4 we have a new concept to learn, and that new concept is finding the sum or difference of cubes. But other than that, the other things that we're doing is a review of old factoring. So I'm going to dig into a couple of problems here for you. And I'm picking off some of the harder ones for you. And the reason I'm saying harder ones is because you have an extra step. So if you look at number 4, all of these, numbers 1 through 4, have 4 terms. So the first thing you should always do, always, is look for your GCF. That's going to make my problem a little bit easier. So these numbers can be a bit overwhelming, and I'm focusing on the 90 and the 108, and I started messing with these. Yep, I can divide all these numbers by 2. I found that I can divide them by 3. I can go up to 6. So I'm going to take a 6 out, and this is where I like to use brackets. I'm just dividing each by 6. That's all I can do, and I'm going to double check that that was the GCF for all 4 terms. And I'm dividing each piece by 6. I'm writing the leftover here, plus 15n plus 18. And the reason I'm using the brackets is because I'm going to come back in and I am going to use parentheses because I'm going to do my GCF, and then my next step is to do grouping. So step 1, GCF. Step 2, I'm looking at grouping. And when I go to do the grouping, you always want a plus sign in the middle. I think all these problems will work out, but if there was a minus sign, you'd want to squeeze that in. So I'm jumping down to here. 6 was my GCF. 40, 48, and 18, they all divide by 2, but 15 does not. And these divide by 3, but 40 does not. So that was my biggest GCF. Nothing else goes into them. So here's where I group the first set of 2 plus the second set of 2. Again, if this was a minus sign, I'd want to keep that with the 15n and not distribute it. At this point, I'm going to keep my 6 in my bracket. And within here, my GCF here is going to be 8n squared. And once I take out that 8n squared, what's left is 5n plus 6. All right, then I bring down my plus sign, and my GCF of these two, just a basic GCF, is going to be 3. Just a 3, and divide by 3, I'm left with 5n again plus 6. So I'm really just doing reverse distribution to get back here. Keeping my little 6 out here, I can keep the brackets. I'm looking at these 2 terms. They both have the 5n plus 6. This is my GCF. I'm pulling it out as a GCF. It's not a quantity squared. I'm not multiplying it by itself. I'm saying, hey, this is a common factor of both terms. It comes out front. Much like 8n squared was a common factor, it came out front. Now, once I pull this out, what's left is 8n squared plus 3, and that's left there in parentheses. I don't need the brackets, but I can leave them. I normally make my answers look like this, but I wouldn't take the time to rewrite it. So if you have this with brackets, I think that answer is perfectly fine. It is 6 times everything. You want to make sure you don't lose that first step. And here are my pieces. And just to remind you, if you take a minute, look at this, that 5n plus 6 times 8n squared comes right back to here. And the 5n plus 6 times 3 brings us right back to here. So that is factoring by grouping. So always check for a GCF on all of these problems. And when there's 4 terms, you're going to group. All right, now, this next set of problems I have, you can use reverse FOIL or breaking up B. This first one, it's real basic because your coefficient is 1, and I'm not going to do it for you, but I will tell you that that a to the 4th needs to be split evenly as a squared and a squared. And in this problem, because a is 1, you'll find factors of 4 that add up to a negative 5. So watch your signs on that. Always double check if you can factor further. If not, you are done. The next one I'm going to jump to, I have 6 here and 8. You can see that these would be a little bit harder because you have a leading coefficient. But notice that there is definitely a GCF. I would say at least a 4, and an a comes out. So take out that 4a, show what's left, which would be 7u to the 4th minus 5. I have to think about what I took out. U squared minus 2. And so I bring this up because you want to keep that 4a here. And this is where you're going to go into reverse FOIL. Or if you like the breaking B method, you would take 7 times negative 2 and work on your factors, and you would write that as 4 terms. But I say on a problem like this, break up your first, break up your last. These are your only options. And then figure out what works for your outer and inner. So you're going to drop in your 7a squared to get the 4 and a 1a squared. And then it's up to you to drop in your -2 or your 1. And remember, you're always testing the outside and inside to see what gives you your middle term. All right, I'm going to take a little more time and work on example 8 with you because there's a little bit more ins and outs here. First thing, I don't want to work with such big numbers, so I am looking for a GCF. 40 obviously doesn't work, 20 doesn't work. I tried all these. I got down to 4 as my GCF. So if I take out a 4, you can use brackets or parentheses. I'm left with a 10p squared plus 57p plus 54. Okay. At this point, I know I got the GCF because 57 doesn't have any other common factors. I'm going to jump into trial and error, and I'm going to jump over to pencil. Now, here's the deal. My factors of 54 will not add up to 57 because this front term changes things. That rule only works when you have a value of 1 because it's 1 times your outside and 1 times your inside. So we have to consider that front number, how it changes things. So if we're looking at this one, my options for the first term in the first slots here are 2 and 5 or 10 and 1. I like to have all my options so I know what I've used. I have a lot of options for 54. I have 6 and 9. I have 18 and 3, 27 and 2, but also don't forget 54 and 1. Now, I'm multiplying to get a positive, so I need the same signs, and I want them to add up to positive. So this is set. I'm content with that, but this is where I get out my pencil because I'm going to do trial and error. So my 2p and my 5p, I know give me 10p. That's what I'm trying first. And then I'm going to drop in a 6 and a 9. This is what I've picked to try. I'm going to remind you with trial and error, I took out the GCF. So if I put a 6 here, I'm wasting my time because there should be no GCF. But just to prove it to you, my last works, 6 and 9 multiply to 54. The question is, am I getting the right outer and inner? My outside is 18p and my inside is 30p. Pretty close, but not 57. Also, the 2 and the 6 should never have gone together, so I could have saved myself that trial. All right, so here I go. I'm going to drop the 9 here and the 6 here. So 2p times 6, that's 12p. And 9p times 5p is 45p. And actually, I've got it. There is my answer. If that didn't work, if that didn't give me the 57 I needed, I would have thrown out the 6 and 9. I would have tried the 18 and 3. But again, I wouldn't put the 18 here. 27 and 2, I would never put the 2 here. So with all of these tries, I can cut them down by 1. So each set, normally you put in and you flip if it doesn't work. But because of that common factor, I only had to try the odd numbers in there. But this is it. I factored it. I got it on the second try. Okay, now on the back. When we look at these special cases, what sticks out to me in these special cases are only perfect squares and difference of squares. There's only 2 terms here, and it has a minus sign, so I'm looking at a difference of squares. There's only 2 terms here, and I'm looking at a minus sign, but they're not perfect squares, so I have to deal with that. Perfect square is going to have 3 terms, and it looks like what we just factored. The difference is there's no GCF here, but it starts and it ends with a perfect square. And in this one, there is a GCF. So I'm going to go ahead and jump into number 11. I could factor this without taking out a GCF, but I would like to take out the GCF, which would be 4. And that leaves me with a 4a squared minus 20a plus 25. All right, so double check your math on that. So I call these 2-step problems. Don't try to go right to taking out the 4 and then breaking it down. Take out the 4, let's look at what we have and just take a step back. Now, if I'm doing trial and error, my first option would be try 2 and 2, but I also have 4 and 1. And if I'm doing trial and error, I have 5 and 5, but I also have 25 and 1. I've always said if you have a perfect square, use that double digit. Use that number times itself. So I'm going to jump in and drop a 2a and a 2a to get my first term. And my last term, I'm going to do a 5 times 5. Now, I need a positive 25, so they need to be plus plus or minus minus. I need the two minus signs because they'll make positive 25, but I need them to add up here. And so if you look at my outside, I get a negative 10a when I multiply, and my inside is a negative 10a. There's the negative 20a that I wanted. Now I'm wishing I hadn't written all over this because I do have to finalize my answer. So unlike the other one where this is my final answer, in this problem, when it is a perfect square and it checks out, I'm going to write it as 4 and then the quantity 2a minus 5 squared. And my final answer should look like that. So I know this is a perfect square. It's in a perfect square section, but that's how you recognize them. Take out the GCF and then look for the perfect squares. That's the first thing I'm going to do with trial and error. If it doesn't work out, then I go back to the drawing board and try another set. Okay, if you look at number 12, same ruling, take out the GCF, which is just a 2. What's left is k squared, and don't forget that minus 1. So this should stand out that there's only 2 terms. I'm going to keep that 2, and what happens is I break this down. If you think about this, this is like having k squared plus 0k minus 1. So I would have k times k, and 1 positive 1 times 1 negative 1. I need 2 factors to multiply to negative 1, but the outside and the inside add up to 0. That is my final answer. It is a difference of squares. You can see the sign change. That's what it looks like. Okay, now the new idea here are the sum and difference of cubes. So whenever you look at this, I still have 2 terms. If you look at all of these problems, they all have 2 terms. What stands out is this power of 3. So that's one tip that I know it's cubic. Now, the other thing is to be familiar with cubic numbers. So how do I put it in the calculator? Well, a square root we know is right here, that square root key. Let me get out of this for a minute. So how do I do a cube root? I'm going to type in the 3, and this works for my calculator and also the multi-view. Type in the 3, and then second, and then the cube root. Now, in my calculator, it looks like this. So the 3 is really in place of your x. You're defining x. In the multi-view, it puts the 3 up in the little power or in the root box as the index, and so it's easier to see. So this is not 3 times something, it's 3 is the x value. So I'm going to take the cube root of 216, and that's 6. 6 times 6 is 36, times a third 6 is 216. I'm also going to look and see, do I have a cube root? So type in my root value, 3, and that puts it in for the index there. And I'm going to take the cube root of 125, and I get 5. And if we reverse it, 5 to the power of 3 is 125. So that's how I can check for cubics. Now I'm going to remind you, I should always take out a GCF first. Now this is called a difference of cubes. So the first rule in this is that I'm going to set my signs using SOAP. So I use the same sign, S, opposite, O, and the last sign is always positive. So that's the acronym SOAP. Use the same sign, the opposite, and the last sign is always positive. I'm going to take the cube root of 216, which we know is 6, and the cube root of a the third. So 6a is the cube root. The cube root of 125 is 5. So the cube roots are what drop down here. And then I'm going to build them up. I'm going to square this. So 6a squared is 36a squared. 6 times 36 gives me back my 216. A times a squared gives me back my a the third. So I'm going to take this term and I square it. So 6a squared. And I'm going to do the same thing with my last term. I'm going to ignore the sign because I've set them. And then 5 squared is 25. And with that in mind, my shortcut, take the cube root, square the first, square the last, first and last, give me back first and last. And this middle term is the product of roots, product of roots, product of cube root. So I'm going to take 6a times 5, and that's going to be 30a. 6a times 5. And this one was, I took 5 and I squared it. I know this is like the only time you're allowed to ignore a sign. That negative sign is set, that positive sign set. So I just pull the values, like the absolute value, and I take the product of that. That's it. This is my cubic difference of cubes that I factored. So 6a minus 5 times the quantity 36a squared plus 30a plus 25. It's really important that you remember the pattern because this is a shortcut. Now this looks like a perfect square. 6 times 6, 5 times 5. The problem is the middle term would need to be 60a. So these trinomials are not going to factor further for us. All right, so I'm going to show one more here. 192 is not a cubic number. 3 is not a cubic number, but that a to the third sort of sets it off. But I'm going to take out the GCF of 3. And so I'm left with a to the third. And let me double check my numbers here. And that would be plus 64. All right, so I keep my 3, and then I'm going to jump right into my SOAP. So the first thing I like to do, this is my method, I do my signs. So same, opposite, always positive. And then I just have a pattern of doing it consistently where I take the cube root and I drop it, and I take the cube root and I drop it. So I strip it down to the cube root, and then I'm going to build it up. A times a squared, so I square it, I get back. 4 times 16, I squared 4, I get 64. You want to actually show the number, don't write 4 squared there. And the middle is the product of the roots. So this would be 4a. And that's it. That is my answer. So this is one of those things, and I hate to say it this way, you know it or you don't know it. We're using a shortcut. So you either know the pattern and how to do it, or you didn't memorize it. Hopefully it makes some sense to you and you can work it out. If we would take the time to distribute this a and this 4 to all these terms and add all the like terms, we get right back to here. Everything will cancel but the first and the last.